So, here is problem of the week, and we've got a really tough probability question here. It's probably as hard as it's going to get at GCSE. I rarely see one tougher than this. There's a couple of approaches that we could take. There's an algebraic method, or there's maybe a sort of a bit hit and miss method. Okay, so we're gonna see what happens. See what happens. Let's have a look. See what the question is. So we got John. Right, he put some counters into a box. He's got some red counters, blue counters. Tells us about wait a minute. I'm going to actually start with this bit just down here where it talks about Linda. And Linda she puts two counters into the box. She takes two counters out of the box. So let's just represent that. So let's draw a tree diagram. So here we go. So let's draw a tree diagram to show what Linda's up to. And we also know here, look, is that the probability she takes two red counters is, so if I call that bit red and that bit blue, red, blue, red, and blue. Mind you, I think John's going to be quite annoyed that Linda's taken some counters from the box. Right, so the probability that she takes two red from the box is 6/155. So the probability of this multiplied by this bit is 6/155. Right, let's go back to this part now and make sense of this. So the ratio, the number of red counters, number of blue counters. Well, if I said what was the probability of picking a ratio of the number of red counters to the number of blue counters. So the chances of getting a red counter at the beginning is 1 out of 5, because there's 5 bits altogether. And blue will be 4/5. Right, now how does this actually help us? Well, we know that this multiplied by this part equals our 6/155. So we also know from that, therefore, that 6/155 divided by 1/5 must equal, that's this other section just here. And we can actually work that out. So that's going to be 30/155. Now, what I would also suggest that you do, because sometimes it's handy when you're messing about with probabilities like this, is that if you write that fraction in a few different ways, let's simplify it to start off with. So if I simplify that, well, 5 goes into both parts, so it'd be 6/31. Think of some other ways I can write it. 12/62, 18/93, 24/124, and 30/155. Okay, I'm going to leave it there. Now, let's come back over here and think about what's happened here. So we know that it's this 30/155, although I've written it down lots of different ways. But remember, I'm taking one red one out, so one's disappearing. So can you think of different ways of writing this? So 2/10, 3/15. Now what I'm looking for is one of these that when I take away one from the top and one from the bottom, it will equal one of the things over here. Now that's probably it's not necessarily the quickest and the easiest way of doing this question, but it's probably the most simplistic way of doing it. So if I keep exploring, I don't know about you, but my eye's getting drawn to this one, and it's because of that 124, because 124 is one less than a multiple of 5. Let's try it. how could I write this one over here? I could write it as 25 over 125. Yes, it works. So how many red counters did John put in the box? He put in 25. So the answer to our problem of the week is 25. There we go. Maybe you could try the algebraic approach. Okay? If you want any more information on that, let me know. And maybe I'll do a different videos to show you how you could get to the answer with a less of a sort of a trial and error approach as we did there. Okay? Right. There you are.